Good afternoon, everybody. Welcome back to the afternoon session. My name is Dr. Scott Butch. I'm the Director of Obesity Medicine at the Bariatric and Metabolic Institute at the Cleveland Clinic and a member of the Workshop Planning Committee. Here to bring in session 3. The title of this session is Applications and Uses of BMI, Body Composition, and Body Fat Distribution. We'll be hearing from 4 terrific speakers today, and we'll have time at the end of the session, again, for the Q&A. Again, the full bios are listed on our links and are found on the workshop webpage. I'm going to introduce the first speaker. It's my pleasure to introduce Dr. Michael Jensen. Dr. Jensen holds the Thomas J. Watson Jr. Professorship in honor of Dr. Robert L. Fry at the Mayo College of Medicine, and is also a consultant in the Division of Endocrinology and Metabolism. Please welcome Dr. Jensen.
Okay, can everybody see my screen?
Yep.
Yes.
Super. So this is going to be a little bit different than the presentations that you've had to date. A bit more biology to give some background about why we're interested in body fat and body fat distribution. So these are my disclosures. And to circle back to why do we care about body fat? We've already heard a lot about body composition today in terms of how we use different approaches to measure the amount of lean body mass that you've got and how much adipose tissue mass we got. But I thought it'd be interesting to go over some of the biological differences that we know about. So for example, in males and females in the BMI range 20 to 25, healthy young women have almost double the percent body fat that men at the same BMI do. And in the BMI range in 30 to 35, in the class 1, where we would call class 1 obesity, obese men have about 30% body fat, very close to the same as lean women, and yet they're becoming very unhealthy. Obese females can have up to 50% of their weight as fat. I wanted to find some good slides to display the discrepancies about how BMI and body fat go together, and Dr. Art already mentioned that they do correlate pretty well, and while that's true, it's also important to note that within a given BMI range, there's a huge variability in the percent of body fat that people have, and people can have the same percent body fat at a very wide differences in BMI. So to emphasize the point that BMI and body fat are not completely synonymous, even though they're highly related, they're also different between males and females. So to circle back, why do we care about it? What are the major roles of body fat? Again, this is kind of getting back to the biology of fat and why we think it's important. And the major role of body fat is to serve as an energy bank. So if you think about our need to store and release energy in order to survive, adipose tissue is a fantastic energy bank. So as an example, if we were to put in a grocery cart the equivalent of one week's amount of food, this would be almost 7 times as much as your body stores in its sugar content. And yet adipose tissue has up to 2 to 3 months worth of food stored in it, of energy stored in it for survival purposes. And yet we carry that around with very little difficulty compared to the effort it would take to carry around all the groceries we need for energy. So how does adipose tissue accomplish all this? Well, when we take in a meal, those triglycerides in the meal end up in our bloodstream, and adipose tissue is very good at removing those triglycerides from the bloodstream and storing them for us. If adipose tissue didn't do that, that meal fat would build up in the bloodstream and could potentially cause fatal pancreatitis. So adipose tissue plays a critical role in helping us process meal fat. And then when we're not eating, adipose tissue plays a critical role in releasing those fat molecules back into the bloodstream for the rest of our tissues to use for energy. To dig into a little bit more detail about that, most of Americans eat somewhere around 100 grams of fat a day. It gets into the bloodstream. Some of it is burned. The rest of it goes into adipose tissue. In an energy balance, adipose tissue releases that amount so that we also oxidize 100 grams of fat a day. It's very difficult to conceive of just how well regulated adipose tissue release of those fatty acids is. To give an example, if we were to think of the fat release from adipose tissue as ideally managed, and we have a woman who requires 1 teaspoon a minute of water, equivalents of fat, to manage her metabolism, her adipose tissue would be a swimming pool that is 80 feet in diameter and 7 feet deep. And yet it is so well regulated, it's just releasing 1 teaspoon of fat per minute from the swimming pool. It's an incredible level of regulation, and it's very important for our metabolic health. So what happens when body fat doesn't function normally? What goes wrong? Well, in this case, the fatty acids that are coming in from the diet may not get into adipose tissue normally, and they may be released abnormally. So, for example, if we have a woman with a BMI in the range of 35 with the amount of adipose tissue I showed you earlier, her swimming pool equivalent of fat would be 80 feet in diameter and 30 feet deep. And a dysregulated release of fatty acids from this gigantic swimming pool, and maybe just 1.4 teaspoons a minute, is enough to push somebody into diabetes, hyperlipidemia, and a host of metabolic problems. This release rate is still just 1/1,000,000th of 1% of all of the fat in the body. That's how tightly regulated it is. And just a slight variation by 40% is enough to cause very serious metabolic problems. You've heard about fat distribution, and one of the things that we've learned over the past several decades is that one of the best predictors of adverse metabolic health is not just total body fat, but where the fat is stored. And people who store fat in the intra-abdominal area or in the visceral area are the ones that are most likely to suffer adverse metabolic consequences. People who store fat primarily in the subcutaneous body fat depots are less likely to develop these metabolic consequences of diabetes and hyperlipidemia. So, does BMI predict visceral fat? So this is some data from our group looking at the relationship between somebody's BMI and how much visceral fat they've got. And you can see that it's a positive relationship, that it's pretty similar for males and females, although females tend to have less visceral fat at any degree of BMI. So it's okay, but it's not great. So BMI does have some prediction for visceral fat. Visceral fat has some predictive value for adverse health outcomes. But what we really want to know is what's going wrong at the level of the fat cell, because the fat cell is the most important cell in adipose tissue when it comes to energy balance. And what do the fat cells do? Well, small healthy fat cells make a good amount of fat storage proteins that help you get the triglyceride out of the bloodstream stored in the fat cell. They're very good at regulating the release of fatty acids. They can release a lot of fat when you need them, and then they can turn off very rapidly under conditions where you don't need fat in the bloodstream. So our research seems to indicate that people with small fat cells do very well in terms of metabolic regulation. When people have large fat cells, and this is whether their BMI is high or not, there's very good evidence that large fat cells become quite dysfunctional. They make less of these important fat storage proteins, so they're not as good at removing triglycerides from the bloodstream. So we see high triglycerides on our lipid panels. They're under fasting conditions, they release too many fatty acids into the bloodstream, which can become toxic. And perhaps even more importantly, they don't shut down this release when they should, such as what should occur after a meal. So it turns out that when we look at that important function of fat cells, the ability to regulate fatty acid release to meet your healthy body demands, that fat cell size, which I've depicted here from one of our papers on the x-axis, is the best predictor of this regulation process. Not body fat, not visceral fat, not the other things. So what our research tends to show is that how big your fat cells are is a more important determinant of how functional or dysfunctional they're going to be than how much body fat you've got, and perhaps even to some extent where you've got it. So what about body mass index and fat cell size? This is, again, some more data from our laboratory showing that while there's a positive relationship between BMI and fat cell size, it isn't great. There's a huge amount of scatter. Some people with low BMI have large fat cells. Some people with high BMI have small fat cells. And so the people with the smaller fat cells are the ones that tend to have better functioning fat tissue. Visceral fat, which we also mentioned, and which is kind of alluded to when we measure body fat distribution, waist circumference, is a better predictor of fat cell size. So people with a very small amount of visceral fat have small fat cells. The more visceral fat, the more we can predict how big the fat cells are going to be. So there's something about this fat distribution parameter that we're measuring that probably tell us something about the underlying biology of adipose tissue, and it's why we're seeing the abnormalities that we see in some people, and probably why some other people are healthy despite the fact that their BMI may be high. So how can we best predict that body fat is dysfunctional? I've already mentioned a centralized fat distribution predicts larger abdominal fat cells. If you can measure visceral fat, it's even better statistically linked with metabolic dysfunction. And this may be because the larger abdominal adipocytes that are dysfunctional and seem to be the cause of a lot of these metabolic abnormalities are associated with more visceral fat. And this is independent of body mass index. And finally, I'll note that fasting hypertriglyceridemia seems to be an early warning sign of adipocyte dysfunction and its ability to regulate energy metabolism. So some take-home messages for the biology of adipose tissue and why we're interested in body fat and body fat distribution. A central fat distribution is a better predictor of metabolic dysfunction than is BMI. At the basic level, we believe that adipocyte dysfunction appears to be essential to the development of many of the metabolic derangements, and that large adipocytes are most likely to be dysfunctional. So I realize this is a bit different than some of the information you received earlier, but I hope that sometimes it's fun to kind of think about why we're measuring what we're measuring and what we can learn from it. Thank you.